Good morning and welcome to this first part of our session on evaporation. In the next few minutes, we are going to provide some definition related to this topic. We'll look at the type of evaporators, what defines or determines the performance of an evaporator. We'll discuss a model for um, multiple effect evaporators. We'll look at the boiling point elevation. We'll revise quickly enthalpy concentration diagrams. We discussed this during our previous topic, that is crystallization. We'll focus more on multiple effect evaporators as a method to improve steam economy. You'll recall that in S3 or S4, you studied uh, simple effect evaporators. Uh, Whereas this time around, we'll focus on multiple effect evaporators. What does it mean? We'll deal with this in the next few minutes. A few definitions. What is evaporation? Now, to evaporate is to concentrate a solution which contains one non-volatile solid, and this is done by boiling away the solvent. And in most practical industrial processes, like in the food industry, the solvent which is encountered there is water. So during evaporations, uh, for example, water is removed from uh, sugar juice or any uh, fruit juice. You have some examples where evaporation is used as unit operation when juice concentrate had to be produced. Um, you can encounter concentration in the production of concentrated sulfuric acid. Water is removed in order to increase the concentration in sulfuric acid. And even when distilled water is produced. Now, in most cases, um, the final product coming from your evaporator is a concentrated solution that we call a liquor. So the concentrated solution which um, comes from an evaporator, let's say for example your juice concentrate, we say that it's a liquor. And of course, apart from the liquor, uh, you always have the vapor which is condensed and discarded if not used in another section of your plant. So you are expected at this stage to be able to define evaporation. You should be able to define a liquor. What is a liquor? Liquor is a concentrated solution that you collect after uh, evaporation. Now, in most cases, the final, let's say, product, so to say, uh, during evaporation is the liquor. The only exception is the production of distilled water. When you are distilling water, the desired uh, output is, in fact, the vapor which is condensed, because water is more volatile than the impurities that you don't want to get in your final water. Now, there are in chemical engineering some other unit operations which are similar to evaporation. And it's very important for us to distinguish between them. You have, on one hand, distillation. What is the difference between distillation and evaporation? In both cases, we are boiling, a mixture, and we hope the more volatile to be converted in its vapor state. Now, the difference between distillation and evaporation is that in distillation, in most cases, both uh, components of the mixture are volatile. There is just a difference in volatility, but but both are volatile. But during evaporation, there is an even very large difference in volatility. In evaporation, we have only one volatile component that we are evaporating. Whereas in distillation, you can have two and more. You evaporate both, but you hope that one will be more volatile and hence will be found in larger amount in the overhead stream. Now, what is the difference between the drying and evaporation? To dry is to remove a relatively small amount of liquid from a solid or another liquid or even from a gas, because remember that you can dry a solid, you can dry a gas, you can dry a liquid, as long as you are removing a relatively small residual amount of water, amount of liquid, volatile liquid from another substance, then you are drying. Like for example, after crystallization and after centrifugation in the sugar industry, you end up with uh, sugar that contains a bit of moisture. Now you need to dry to remove that small amount of water. Now the difference between evaporation and crystallization: in crystallization, the product is a slurry of crystals which is precipitated from solution. Whereas evaporation, we said it, we repeat it again. Evaporation refers to the removal of a relatively huge amount of solvent from a non-volatile substance. What are the types of evaporators? Now, evaporators can be classified on the basis of the configuration as well as the degree of agitation for the liquid phase. But in all evaporators, you always encounter three major parts. Evaporators consist of three major parts. The first one is a heat exchanger, where heat is added to the mixture in order to vaporize or to evaporate, depending on the cases, to evaporate the volatile component. And number two, you have to get in your evaporator a vapor space or a vapor head, which is a chamber in which liquid and vapor phase are separated. Uh, that part is helpful. It's used to ensure that as your liquid is evaporating, the vapor phase uh, doesn't carry along liquid droplets. Then you have always a liquid mover, which can be a pump, and sometimes they take advantage of just gravity in what we call falling film, falling films evaporators. Now, these are the three parts. The heat exchanger is the chamber or the vapor phase, and here they are using just gravity to separate. So thank you very much. This concludes our first part.